balancing equations. So the redox reactions we've been doing in the previous videos, okay, using the oxidation number. However, this time we're going to be using half reactions, okay, so the half reaction method. This stands for reaction, okay? And we're only going to be relating this to acidic solutions today, okay? For the next video, we'll be doing the basic solutions. So how do we start this off? Okay, again, in the previous video, we looked at the oxidation number method over here, right? So again, have a look at that video. Okay, the link is in the description. Please look at that as it is a prerequisite to this video. When we did that method, we used these particular steps. When we use the half reaction method, which is what we're going to be using today, okay? So not this. We're not doing this one today. We're doing this one today. The half reaction method, it looks a little bit different, okay? So step one actually looks the same, okay? So our step one is going to be the same. Assign the oxidation number for each atom and identify, remember, oxidation is the loss of electrons, okay? So we're going to have to find the oxidizing agent and the reducing agent, okay? Obviously the reduction here stands for the gain of electrons, okay? So step one is exactly the same. However, step two becomes a little bit different, okay? So step two is, instead of determining the amount of electrons lost and gained right away, we actually want to start balancing, okay? So balance right away. But we balance using the half reaction method, okay? So again, that video, the video that I referenced, okay, for you to look at with the link in the description earlier on, talked about the half reactions, okay, how to split them up into half reactions in the 20-minute version, okay, not the 2-minute version, but definitely have a look at that if you haven't already. So once you use this half reactions, we immediately need to go all the way up to just the oxygens and the hydrogens balancing. Okay, so we need to go all the way up to there, and I'm sure you do this anyway whenever you balance out your equations. Once you get up to this point, okay, which you're used to, you then have to start balancing this and this using water molecules and hydrogen ions, okay? So the oxygen over here, you balance using the H2Os, and the hydrogens you balance using the hydrogen ions. And I'm gonna write here, balance the O's, right, the oxygens with water molecules, and balance the hydrogens with the hydrogen ions. And then step number 3, we have to see and observe if this balancing method that you've been doing up to step number 2 created discrepancies with the charges, because now the charges are going to be all messed up, okay? Because you're going to have cations on one side and maybe even anions on the other side, or you can have both on either side, and so it's going to really mess up with the charges. So when you have a mess up of charges, this is when we start dealing with the electrons. So step 4, you need to balance the net charge by adding electrons and make the electrons gained to equal the electrons lost. And then step 5, you finally add those half reactions. And you cancel any like terms. And we honestly should be able to completely balance it out naturally. So let's start with this question over here. We obviously first have to get our oxidation and reductions. So let's figure that out. Okay, so this whole thing here doesn't have a charge, so it's got to equal 0. The charge for oxygen is typically a -2, so 2 times -2 will give you the -4. We have 1 charge over there because that's typically for the group 1 elements, right? And we have 3 of them, so 3 times 1 will give you 3. So 3 plus what? -4 will give you the 0. Obviously a 1, so this one has to be a 1. And this one over here, the whole thing needs to equal -2. So again, oxygen is typically a -2, so 7 times -2 will give you -14. Obviously, we need to figure out 2 times what will equal our 12, because we know 12 minus 14 will give us that -2. Okay, so obviously 2 times 6 will give you that 12, so that we can eventually sum it up and get that -2. Okay, so 6 and -2 would be these ones. Next, this whole thing needs to equal 0, so 4 times, again, -2 is the charge of the oxygen, so 4 times -2 will give you -8. 3 times, again, typically is a 1, right, for these alkali metals. Okay, hydrogen is not a metal, but it's still a group 1 element. It's typically a charge of 1, so 3 times 1 gives you 3, plus what? -8 will give you that 0, so obviously it's going to be a 5, all right? So 5, 1, -2 are going to be these oxidation numbers. And this last one here has a charge of 3. It's a free ion, okay, so it's going to obviously be a 3 charge. Okay, so let's establish the oxidations and the reductions. Okay, so everything remained the constant, right, for the hydrogens and the oxygens. So obviously it was the P's and the chromiums here that kind of got changed. Okay, so let's start with this one over here. This is pretty obvious. 6 became 3, so it got reduced. So obviously this is a reduction. This means that it gained 3 electrons. And then the P's over here. All right, what happened to those? Well, it was at a 1, now it increased to a 5. Okay, so that increase of oxidation number is oxidation, which means that how much did it lose? It obviously lost 4 electrons. Now, if you use the oxidation number method like we did in the previous video, you would right away multiply this one here by 3 and this one here by 3, so that this whole thing can equal 12, right? And then you would do the same thing for this one over here, right? So this one and this one, you would multiply this by 4 and you multiply this by 4 to also give you that 12. So in the previous video, this is what you would be doing. I want you to obviously try to make a chart of this on your own using the balancing reference chart that I had talked about last time. Okay, so obviously you would have, you know, chromiums, and then you would have like your phosphoruses, and then your oxygens, and then your hydrogens. All right, try these out. Okay, try this on your own and look at how difficult it's going to become if you do not use what we are using, the half reaction method. Okay, see what numbers you get over here and see if it's possible. All right, pause the video, give this a try. Alright, so this is typically what you should be getting, okay? So obviously we need to make our oxygens over here equal, right? And normally we'll be doing the chromiums first, right? But thankfully we have chromium here on the side on its own, so it must be a good thing to have that alone so it doesn't get messed up if it was with a compound. So let's first do the oxygens, right? Once you do the oxygens, then whatever leftover chromiums that you need to kind of balance out at the very, very end, you can easily do that with this guy here being alone, okay? The problem though, when you just look for the oxygens, you're gonna have to obviously change this one over here because oxygen is part of that compound. It's going to really mess it up, right? It's going to mess up the phosphoruses and it's going to mess up the hydrogens, and that kind of sucks because we have our our phosphoruses here really well balanced and our hydrogens really well balanced. But if you wanted to just balance with the H2Os right away, like here in step 2, this is going to really mess it up too, because if you, let's say, put H2O over here, here's the problem. You have to make this one over here a certain number so that it adds with 12 in order to give you that 34, okay? So obviously that would be 22, right? Because 22 plus 12 will give you that 34. So how are we going to make this 22? Well, if you add a 22 over there, that's obviously going to make this one become the 34, right? Because you have 22 here, we have 12 over there, you add those up, you then get that 34. However, it really messes up our hydrogens because our hydrogens used to be at a 9 here. If you do that 22 times 4, then this one will obviously become a 44. Seems like that oxidation number method of balancing out really is a problem. Okay, we definitely do not want to use it. So this is why we have to balance right away here using the half reactions. Do not forget to do the half reactions first, splitting them up this way before you start balancing any of the oxygens with our H2O, or otherwise it's going to become really messy like this. Again, so we know which one is oxidized, right? So we're going to be putting our oxidations, our H3PO2. Okay, so let's write that here, H3PO2. And then you have to yield that to our H3PO4. Okay, so let's write that over here. Now that we've done that, we've split it up into its half reaction. We can do the same thing for our reduction. Okay, so our reduction is this one over here. So let's write that down. Now that we've done that, we notice how there is a certain problem, okay? We are not necessarily balanced. We should always balance right away, okay? So we're gonna balance it, putting a 2 over here so that it balances that 2 chromium. So now that we have that, we are good. The problem now is, remember, we balance right away, but you also have to use the half reaction method, okay? So if you want to split this up into kind of 2 little categories, balance right away first, and then balance using the half reaction. You can rewrite this little note over here on your own if you want to do that, okay? Just know that you always got to balance first and then balance using the half reaction. So again, we've balanced the chromiums, we've balanced the chromiums there, okay? The only thing right now that we haven't balanced is our oxygens, okay? Because this one obviously has 2 oxygens up there, this one has 4. So how do we balance the oxygens? Again, we balance all the way up to the oxygens and the hydrogens, which is the point that we are at right now, and we balance the oxygens using the H2Os. So obviously I need to put an H2O over here. Okay, now the water, the H2O, needs to be a 2 in front of it because we obviously need 4 oxygens, okay? Because there's 4 oxygens there, we need 4 over here, right? So then 2 plus the 4 oxygens, sorry, 2 plus the 2 oxygens there will give you the 4 oxygens, all right? So we're going to do the similar thing over here as well, okay? So the similar thing over here, there's oxygens on the left side, we have to put the oxygens on the right side, okay? So again, we have 7 oxygens over there, so we got to be putting 7 H2Os here because now we have 7 oxygens on the right side. Now we got to start balancing the hydrogens, okay? So how is our hydrogens on the left side here versus the hydrogens on the right side over there? Well, we have 3 over here, okay? And then how much do we have over here? We have 2 times 2 gives us 4, so 4 plus a 3 gives us 7, okay? However, we only have 3 hydrogens here. That's a problem. So we need to make 7 here as well. So obviously we're just going to be plus 4 hydrogen ions, okay? Because remember, we balance the hydrogens with the H pluses. And we got to do the same thing down here, okay? So we have 14 hydrogens over there, okay? How many hydrogens do we have here? We don't have any. So we actually have to add over here 14 hydrogen ions, okay? So now our hydrogens on this side are equal to the amount of hydrogens on that side. So I'm going to slowly bring this upwards where it needs to be, where it's a little bit more clean to look at. Again, this is our oxidation, right? So we're putting our H3PO2 added with our 2H2O to become our H3PO4 and our 4 hydrogen ions, okay? And this reduction one over here is going to be right below it, our Cr2O7 2 minus, adds with the 14 H pluses, and then makes our 2Cr3 plus our 7 H2O. Now, what do we have to see and look at? What does step 3 say? See if this balancing method created any discrepancies with the charges, okay? So we have 4 H pluses, so again, these are all 1 pluses, right? So 4 times 1 will just give you 4, so you have a 4 plus charge over here. The problem is there is no charges over there. So we have 4 here, 0 here. So how do we make it balanced? Well, as long as you add 4 electrons, because these are negatively charged, this will make it neutralized, okay? So now we have 0 here and 0 here, which is awesome, okay? Now we're going to do the same thing for this bottom one here, okay? So how do we do that? Well, there is a 3 plus charge here. There's 2 of them, so then this becomes a 6, okay? However, on this side, what do we have? Or this one, this 7 minus should actually be a 2 minus. I don't know why I put a 7 there. Okay, so this is a 2, okay? So we got a 2 minus over there. So we have 14 H plus, so it's a plus 14 minus the 2 over there. That gives you a 12, okay? So we have 12 over here and we have 6 over there, okay? So how do we make this 12 become a 6? Because they need to be the same. Well, obviously on this side, you can only add electrons, right? And electrons are negatively charged. So if we add an electron, how many electrons does it need to be, right? 12 minus how many electrons will give us that 6? Obviously, 6 electrons, right? Because then now you have 12 minus the 6 to give you that 6. So that's perfect. So then now we have 6 electrons over here. Here's now the problem, okay? We have to make sure that this 4 electrons and this 6 electrons are the same. If they're not the same, then how do we do step number 5 here, okay? To cancel any of the like terms. Even in step 4, we even say that the amount of electrons gained must equal the amount of electrons lost. So this one here and this one here must be the same. So what number, the lowest common multiple, is it going to be that both 6 and 4 can multiply into? Obviously a 12, right? So then we have to multiply this one here, everything by 3 to give you that 12. And this one here, you have to multiply everything by 2 to also give you that 12. So let's do that down here. So this one, this H3PO4, okay, it multiplies by that 3. So then this H3PO2 needs to multiply that by 3. So then you get a 3H3PO2. And then this one here multiplies that 3 over there, so you get 3 times 2, gives you that 6H2O, yielding, again, 3H3PO4. This times that gives you that 12H plus, and now we have that 12 electrons. Okay, you do the same thing down here, so you get 2 Cr2O7. And then we get this 14 times 2 gives you that 28 H plus. Oh, we can't forget the electrons over here, so 6 times 2 will give you that 12 electrons. And then this one over here, we have 4 chromium ions, and we got our 7 times 2 gives you 14 H2Os. Now, what does it say for step number 5? You have to now add the half reactions, and then we can finally get rid of those annoying like terms like this 12 electron and that 12 electron, okay? So now we're on that final step for step number 5, so let's add it all up. We get 3 H3PO2 added with our 6 H2O, added with our 2 CrO7 2 minus, with our 28 H plus, the 12 electrons, yielding the 3H3 PO4, the 12 H pluses, the 12 electrons, the 4 chromium ions, and the 14 H2O. So let's cancel out the like terms. The 12 electrons here is the same as the 12 electrons there, but we are actually not done. As you can see, there are H2Os on both sides, and there are hydrogen ions on both sides as well. So if we have 6 over here, we can actually completely get rid of it because there is a 6 over there, right? But obviously this is a lot more than 6. It's a 14, right? So we can actually just get rid of the 14 and just subtract the 6's, so now we have 8. We can do the same thing for the hydrogen ions over here, right? We have 12 over here, we have 28 over here, so we can get rid of the 12 here, and then we just minus that 12 by this 28 over there, so then obviously you get 16. Alright, so now let's just make sure we have our therefore statement, and everything looks a lot more clean right now. We have 2 CrO7 2 minus, plus our 16 H plus, yielding our 3 H3PO4s, our phosphoric acids, and then that's pretty much it. 4 Cr3 plus and H2O. That should be your answer. All right, let's try another one for good measure. We have this one as an oxidation number of 3. We have this one here needs to equal -1. Again, this is typically a charge of -2, so 3 times -2 gives you -6. What does this number have to be to -6 to equal -1? Obviously a 5. Okay, so this one just becomes a 5. And then this one over here, it needs to equal -2. This is typically a -2 charge, so 7 times -2 gives you the -14. What number times 2, right, will give us that 14? Will give us that 12 to -14 to equal -2. Obviously, it has to be a 12 over here, so we have to put a 6 up there, because 6 times 2 will give us that 12, right? And then this one over here is obviously just a 3 oxidation number, because it has a 3+ charge, and it is free element, okay, free ion, it's alone. So now we have to just do our oxidations and our reductions. So obviously this one over here goes to there, okay? 3 increases up to 6, which means that this is an oxidation, so it lost 3 electrons. And then this BiO3 over here becomes the Bi3+, so we have 5, it went down, so it got reduced. Okay, and that means we lost 2 electrons. Sorry, we gained 2 electrons. Okay, it's a little bit more negative now. Okay, so let's write down our oxidation here first. So our oxidation is our Cr3+. Let's make it into a half reaction. What does it become? It becomes Cr2O7 2-. Okay, and we'll do the same thing for the reduction. We have our BiO3 1- becoming our Bi3+. Again, we have to make sure that they are balanced out appropriately. This one is obviously not balanced out with that one. Okay, so we're going to just put a 2 over there. So now we are balanced. We've done everything up to O and the H's. Okay, so now let's start off with the O, and then let's do the H. Okay, so where is our O? We got 7 over here, so we got to be putting 7 over there. We do that by putting H2O's, right? So we'll put a 7 H2O over there. Now we've messed up our hydrogens. Okay, so we got 7 times 2, 14 hydrogens over here, so we're going to be putting 14 H+ there. And remember, we always try to make sure we balance our H's with our H+. That's what we've done down there. Okay, so same thing with our BiO3. Again, the BI's are balanced appropriately, but the oxygens are not. So we got 3 over here, so we got to be putting 3 H2O's over there to balance out the oxygens. Our hydrogens are now messed up, so we have 6 over here, so we have to be putting over here 6 H+. And then we have to make sure that our discrepancies with the charges can be balanced out appropriately with our electrons. Okay, so let's bring this one up here with the amount of electrons that are needed. All right, so let's look at the electrons that we need to add. So we got 2 times 3, so that would give us a +6 over here. How about here though? Okay, so this is a +6. How about here? We got 14. Okay, so we got 14. However, this is a -2. Okay, so then this would be a 12. All right, so obviously we have to add 6 negative electrons over here so that it can equal out that 6 on the left side. Okay, so we're just going to add, we're just going to add 6 electrons over there. Okay, we're going to do the same thing down here. What is our particular charge? We have 6 times 1 pluses, so we got 6 over here. -1 will give us a 5. Okay, however, this one here on this right side over here, it's a 3+. Okay, that's all we have. So how do we make sure that this equals this? Well, you just have to add 2 electrons over here, because 5 minus 2 will give you that 3. Okay, so we're going to add 2 electrons there. So let's rewrite this again so that it's nice and clean. Alright, so we've done that over here. Now we have to make sure that they are the same. Okay, so this is 6 electrons. Obviously, this one here is only 2 electrons. So we have to multiply this whole thing here by 3 so that we can get 6 electrons. Alright, so let's do that just for this equation down here. So we have 6 electrons plus 3 BiO3 1- plus 18 H pluses, 3 Bi 3+, and 9 H2Os. Alright, so now that we have these two equations nice and ready to be added up, right? Because obviously step 5 we gotta finish it off by adding the half reactions. So let's just get it right over here. So we got 2Cr3 plus 7 H2O plus 6 electrons plus 3 BiO3 plus 18 H pluses yields our Cr2O7, 2 minus plus 14 H plus 6 electrons plus 3 bismuth ions plus 9 H2O. Alright, so let's cancel out the like terms. So our 6 electrons get canceled out. Obviously, let's look at our H2Os and our hydrogen ions. So we have 14 over here, we have 18 over there. So if we get rid of this whole thing, we just have to subtract this 18 by the 14. So we just get 4 H pluses, okay? Oh, this doesn't look like that H, there we go. Okay, and then we have to make sure to do the same thing for the H2O. So we got 9 over here, we only got 7 over here. So let's get rid of this whole thing, subtract the 7 from this 9, so then this one becomes a 2. So let's make our therefore statement and put it all clean in order. So we have 3 BiO3 1 minus plus the 4 H pluses yields our Cr2O7 2 minus plus our 3 Bi3 plus 2 H2O. This should be your answer. Please try these two questions on your own. This here is the first one, this here is the second one. Pause the video and I'll be giving you the answers shortly. This is the answer to the first question. I will slowly scroll down. And this is the answer to the second question.